Hi everyone. Thank you for your time and interest in ETAP STAR AutoEvaluation, which stands for Automated Protection Coordination Evaluation. My name is Piruz Barfordar. I'm a Protection Division Manager in ETAP and also the designer and product manager of STAR Auto. Our webinar for today would be consisting of 5 items as the agenda. We will briefly go through the development history, then review the general procedure for protection and coordination studies. We'll have a look at the features and capabilities of STAR Auto and compare it with the traditional procedure. At the end, we'll have a look at who can be the target users and what could be the incentives and benefits if you decide to use this application. So without wasting any time, let's continue. I would like to remind you that we would very much appreciate your feedback, comments, and questions. So if you like to send any feedback, comments, or questions, you can use this pane in the UI for this webinar. If we have the time during this webinar, we'll answer the questions or make comments regarding your suggestions. Otherwise, we'll get back to you after this webinar is finished and we have enough time to review and respond. Okay, looking at the development history, as you may know, we have spent more than 5 years for design, development, and testing of this feature. STAR Auto has been introduced and added as a new feature to ETAP 14. So if you have ETAP 14 or any release after, like 14.1 or the 16, which is going to be released shortly within this year, then naturally you would have the possibility to purchase it, get the license for it, or maybe do a test trial or trial version of it to see how you like it. At the end of this webinar, we are going to have a special announcement regarding the promotion we are planning to have because of the ETAP 16. So I draw your attention to the end of this seminar. John Francis, who is one of our sales director, will talk about this promotion and provide you with the contacts and links how you can correspond to be benefited from this promotion, which is a special discount for STAR Auto. One thing to be noticed for auto evaluation or STAR Auto is the major difference between this feature and other engines we have in ETAP. Typically, an engine is referred to a calculation engine, but STAR Auto is a special logical and intelligent engine. What it means is the artificial intelligence of the protection engineer has to be put into the engine in the format of logics to be able to do analysis, the protection and coordination studies based on the rules that we are providing to this module. As such, naturally, we had to hard code the know-how of the protection engineer into the software, and you may know how hard it was to do it. And additionally, since there is no unique design criteria for doing protection coordination studies for any project or any part of the world, then we have given you the flexibility to customize the rulebook based on your needs or your desire or your preference. We'll go through it as we'll go through the overview of the features. So naturally, for doing all of this, we have spent thousands and thousands of hours for design, development, and testing, not to mention it. Starting with the prediction and coordination study procedure, naturally the first step would be to model the system. The minimum requirement for modeling any system to do the prediction study is to start with the impedance network. It means you create a one line. You fill in the required data for each of the impedance elements, like the cables, transformers, putting the ratings, and then filling the protection landmarks. To translate this requirement into ETAP, as you know, if you have an electrical network like this, the first step is to create the one-line diagram in ETAP, as we have done it already. Then the next step is to fill in the data for each one of them to create the impedance network. This data could be for the transformer. So for the transformer, depending on the standard, rating, and impedances, you would fill in the data. At the same time, you need to fill in the required landmarks for protection of the transformer. Naturally, it may depend on the standards, such as frequent or infrequent fault for the damage curve of the transformers, which depends on the ANSI standard. But if you select IC standard, such criteria does not exist. So the program or Star Auto can intelligently make a distinction between the two and evaluate each one of them. Other criteria or the landmark could be, for instance, the inrush current, as you can see here, or it could be the FLA, or full load ampacity or capacity of the transformer. The same applies to other impedance elements like cables. You need to have the length of the cable, have the impedance of the cable, and again, for the cable, you need to select the proper criteria for protection or representing the damage curve of the cable, in addition to the FLA, or total ampacity or capacity of the cable. So you know what I'm talking about when we are talking about the impedance network and filling the requirement for impedance and the landmarks for the protection. The next item to fill in as the model requirement would be the protective devices. For protective devices such as relays, breakers, trip units, fuses, overload, heaters, and etc., what you need to do is you need, in ETAP, in the one-line diagram, you need to select these devices from the library, such as this one. So, as you know, we have a huge and extensive protective device library in ETAP, such as this one for all of the fuses for different manufacturers, as can be seen, right? So you just need to select a model from the library. This model doesn't need to be necessarily the model and the size that you would like to be used in this project. If you're modeling an existing system found at the site, naturally you should select exactly the same model, same size, and same setting. But if you are working on a design project, typically you are starting with a specific manufacturer and selecting the specific type of the cables, and as we'll see, different sizes or trip unit that you select would be detected by the program to tell you a warning or giving a failure message if it does not fulfill the requirement for protection and coordination study. To save the time, naturally, you can start with a better selection in the beginning if it's a design project. If it's not, it's an existing or as-found project, naturally, you would have no other choice. So after filling the data, this means that you have a system that is ready to be used for protection and coordination studies. For doing a protection coordination study, the first requirement is to run the fault studies. Depending on the type of the protection element or functions modeled in your system, you may want to apply phase fault, ground fault, or account for the true fault current. Then in the next step, you select the zones of protection, such as motor, load, bus, cable, line, transformer. Then create a time current curve for each of these zones or a group of these zones. And depending on your expertise and knowledge and know-how, you evaluate or analyze these time current curves, typically by visual comparison of the time current curve with the operating or damage curve of the equipment, if it is protection, and the time margin between the time current curve of the protective devices, if it is coordination. Again, if we want to show this stage of study in STAR mode, which is the mode for protection and coordination studies, what you can do is you can select any portion of the network, like this one, and then simply press this button, create a STAR view, and the program would simply and easily create the time current curve for this group of the elements with the one line, as you can see. And as can be noticed, this selection is dense and condensed because of the number of the elements, right? So typically you need to split this time current curve or STAR view in multiple and smaller zones of protection, such as this motor zone, and create individually time current curve or STAR view for each, like this one, right? And then you need to repeat the same thing for the next and apply any required protection any correction in the setting for the protective devices to make it acceptable by the rules of protection and coordination that you are knowledgeable enough to apply. So we have to do one by one for each, as I showed you. And then what you do is you select the next adjacent zone, which is the bus, and do another time current curve for this zone, create another STAR view, and then you need to go back and forth, make sure changing and correction of one of these settings does not change the other. All right, you need to make sure that they are consistent and follow the same procedure and go on. Naturally, this procedure is time consuming, and depending on the number of the buses, number of the protective devices, and naturally number of the zones, you need to spend more and more time. That's the nature of the protection and coordination study. In ETAP 12, we have introduced a nice and powerful tool which is called Zone Viewer, which can be used handy for split of the zones in multiple smaller zones. So if you select this portion of the network, what you can see is the protection zone viewer becomes active. And from here, if you press this button, it would split this portion of your network into individual zones. And when you select each one of them, the respective zone would be highlighted on the one line. So this is IM13, IM12, IM11, and this is the bus zone. The other were motor zones, and this is the bus zone. From here, and create individual star view, right? If you want to, and then by pressing this button, the program would create all of those star views, which we said you have to do one by one, but still you need to switch between them and remember what you have done between all, and make sure you have noted or documented your changes as you move upstream or moving forward. So this is a traditional procedure for doing the protection and coordination studies. For coordination, as we said, you need to apply the time margin between the upstream and downstream devices, depending on if they have a ban or don't have a ban. Now, let's see how we are doing it in star auto evaluation. If we look at star auto evaluation features, what it does, it brings and combines all of these steps into a single feature or engine which takes care of everything. This means it would automatically and intelligently detects all of the protection zones. It would automatically evaluate all of the protection and coordination zone. What I mean by all is all of the selected zones from the one line. So it's up to you to decide the whole one line or any portion of the network that you would like to do the protection and coordination studies. Then, as we said, since there is not a unique rule to do all of the protection and coordination studies across the board, the program is giving you the flexibility to customize these rules of protection and coordination, although we are providing a default ANSI, NEC, and also IEC rule books, which is based on the standards such as IEEE 242, the buff book, and IEC standards, which can fulfill most of the requirements. But if you still have any other preference or desire to change any rules, you can do so. So let's have a look to see how these three features that I have introduced to you works in star auto evaluation. As I said, you can select any portion of the network, or you can use and select the whole network, right? Once you select the network, these buttons, which is star auto evaluation, becomes active. You can put a name for the report, and you just press OK. What it would do, it would collect all of the information from the individual elements, the equipments which are contained in each zone for protection, and also the protective devices, automatically runs the short circuit and put the pulse at the proper location and gives you the result in a simple table. In this table, if you like, you can sort the results based on the status. Red with a cross sign means it has failed the evaluation criteria based on the provided rule, and orange means the protection engineer needs to pay attention to the found observation for evaluation and decide if it is acceptable or not. If it is green, it means from the software standpoint, everything is fine. So if I go to any one of these zones, like this one, you can see the program has found that the maximum trip unit, 3000 amps, for magnetic portion of this thermal magnetic breaker is above the maximum limit, which is the lock rotor current of the motor multiplied by 200%. So it is 3000. It's a bit about above the 2964. You can make a comment that this is acceptable, but if you wish to even correct this one, what you can do is you can go to the editor and put a smaller number like 9.5, and that would give you 2850. Pressing OK would fulfill the requirement for this portion of the network, and the program would update the results based on new inter data, so you don't have any problem for this motor. As you can see in the analysis viewer, we are automatically evaluating the protection zones, providing the results in the general page as a summary. The zones of protection are consisting of bus, cable or line, generator, load, motor, and transformer. And for each individual criteria applies, like the pickup limit, full load current, inrush, and the damage curve. For instance, for this transformer, the program is drawing your attention that there is an intersection between the time current curve of this relay, this one, with the damage curve of the transformer. You can observe the same tabular and graphical results for the coordination studies as well, such as this one. There is no coordination between this cable, no coordination between these two due to the overlap of this one. And for this bus, this low voltage motor circuit, motor control center bus, you can see that we have failed because there is instantaneous overlap between the main and downstream breakers. And the program is giving you the range of the failure, the pulse current that's starting and causing this miscoordination. So if I drop a crosshair and bring it here, then I would see this number is matching this criteria. You can have a look at all of the coordination elements within the zone if you select the upstream, or you can see each pair to see what is the range and coordination criteria, if it's a miss or not. And the program is giving you the message what is the range, what is the voltage, what is the fault current, and what is the margin or time interval for coordination between any of these two. I've showed you automated evaluation for protection and coordination in Analysis Viewer, which is part of the STAR AutoEvaluation. Let me show you the rulebook that we use for such evaluation. If you go to Rules, select STAR Auto. By default, we are providing you with two rules. One is for the ANSI or NEC, and the other one is by IEC. As you may know, there is really not a large difference between the protection and coordination rules between the two boards. The major difference depends on the standards and the tests for the apparatus or the equipment you're trying to protect, such as motors, which applicable standard is a bit different than in ANSI board compared with IC board. So these are the two rules that we can use and observe any criteria for cable, induction motor, and transformer. As you can see, we are following the NEC standard, National Electrical Code, Table 453, and exactly following the rules of the protection for the load side and source side of the protected devices. We also consider availability or existence of the protected device on the secondary, and if it does not, automatically move to the criteria for the protection by the source side and change the rate. So it's very intelligent, very flexible. You cannot change this rule because this is ETAP rules, but if you want to make your own rules, what you can do is, for instance, select IEC, press copy, and then select a name for it, like my rules. Press OK, and then if you press edit, in addition to the first page, you have the option to edit any percentage for the maximum pickup setting for the low voltage or high voltage cable. For the protection of cable and the similar elements or equipment, we have two criteria. One is for the pickup evaluation or threshold evaluation, and the other one is for the damage curve or operating curve evaluation, as we call it, protection evaluation. So you have threshold and protection evaluation. At the bottom, you see some options for proximity check. This will be additional accuracy, providing you to make sure that the margin between the time current curve of your protective devices with the damage curve or operating curve of the equipment is enough based on these percentages. So, as I said, you have the rules for the protection and proximity for the induction, synchronous motor, high voltage transformer. As you can see, even in IEC, we suggest to use NEC table because it's the IEC practice too. If we go to the coordination page, you see the time margin between the time current curve of the protected devices, what is called as time interval, or as we call it, minimum time gap in second between any upstream and downstream protected device. For relays, we are accounting for the breaker opening time individually. So if you have entered the breaker opening time of the breaker in the editor, we use that one. If not, we'll use the default, or if you haven't entered in, you can use the global. We also have the option for coordination between the main and tie and the instantaneous ratio. So as you can see, any one of these, like this time margin, can be changed, and you can type in whatever you want, and then follow these rules. In addition to Rulebook, as I showed you, we have a specific page for Star Auto in study case that you can select the type of the evaluation, protection, coordination, or protection and coordination, and also select the fault type, which is phase, ground, or both for the coordination. So what I have showed you is evaluation of the fault current and type selection study case, in addition to what we have discussed before. As we have seen, we have tabular and graphical display of evaluation results. And for reporting purposes, what you can do if you select, let's say, the whole one line, and then run the evaluation, then the program, as I said, will collect all of the data, apply the selected rules, and evaluate the result. The results of such evaluation is displayed in the tabular format and also in the graphical format. And what you can do is, if you're interested to make a report for each of these zones, what you can do is you can select any one of these graphicals. We have tools at the top, capture star view into clipboards. So if I press this one and press on the star view, then a copy of this star view would be copied into the clipboard that you can paste it on a third-party application like Microsoft Word. So if you're preparing a report, this could be part of your report. And at the same time, you're creating a report. So if for this evaluated system, if I go to the report manager, evaluation, and evaluation report, and press OK, what I would see would be an evaluation report, which is representing the project information, the same table that we had in the general page, and for each of the zones, all of the evaluation results, if it is pass or failed, could be included. So you have tabular and graphical report. This table could be directly attached to your report, or you can copy and paste it into a report if you wish to. Another nice feature we have in Star Auto Evaluation, as I showed you, is the dynamic correction of these elements. The general procedure for the Star Auto Evaluation is to create a revision for as found if it is already existing system, or you can create a new revision, like you can go to rep control, copy, and make a copy as found to my suggestions. Press OK, and then start making corrections in these new revisions of ETAP. So once you are in this new revision, the suggested procedure for doing the protection and coordination study, even in Star Auto, is to start with the downstream zones or apparatus or equipment such as motors, together with the adjacent bus. Then once you run the protection and coordination study with Star Auto, you can go to each and start with correcting of each of them. Typically, when you have a combination of the cable and motor, you better start with the motor because the cable is in service of the motor. So for the motor, as you can see, we have overload heater issue here, and it's telling you that the trip amps 81.7 is above the 115% of the FLA based on NEC rules, and that would be 65.4. Here, notice that when you are selecting the motor, the respective element becomes highlighted. Also, if you select the protective device ID, those IDs becomes highlighted on the one line too. So that's a handy feature if you have dual screen. So if I want to correct the overload heater, what I can do is I can come here. So imagine that if this was the design project and you have selected something which was not the right size, you can easily come here and adjust the size and press OK. Then the program would automatically update the results for you. All right. This is for the overload heater. For the MCP, and you don't need to go to the editor. In Star Auto, you have the capability to correct the setting both graphically and from the editor. So in this case, what I can do is I can simply grab and push the MCP to the right, and that would automatically correct the protection for this motor. If I go to the coordination, then I would see the program is reporting the miscoordination, but as you can see, all of the miscoordination, as we discussed, is because of the overlap of the instantaneous region or instantaneous portion or segment of the breakers, and you can check it with the cards. So this is what can be done in as a general procedure for automated protection coordination evaluation 2. But we have another nice and handy feature in the analysis viewer that can be helpful when you have larger projects. Naturally, if you want to run the evaluation, it needs to consider the portion of the network that you have selected and run the pulse analysis for the whole system. So that may take time for a very large project or large project. In order to save time, what you can do is what I'm showing you. Let's say I'm selecting the protection and coordination for this bus. If I select this bus and then run the protection and coordination study in Star Auto, if I go to the bus, what I would see is it's telling me that the LVCB rating of sensor amp is greater than the bus continuous amps. which shouldn't be a big deal, but it can be verified to see what are the settings. So if I want to check this rating or setting, what I can do is first check the bus to see what is the rating of it. And if I go to the rating page, this is a 2000 amp bus. So if I check the setting of the long time pickup for this breaker, you can see it's 2500 amps, but it is set at 1000. So it needs correction, right? One of the possible correction is to increase it or change the sensor. But let's have a look at the coordination also before making any changes. So what you can see here is due to the reduced pickup, you have this problem here, right? Which means you have overlap, or the upstream breaker is below the downstream, causing miscoordination for this range. Between these two, between fuse and the breaker, there is no miscoordination as can be seen, but between the upstream breaker and downstream, there is. If you want to run a study and make multiple modifications without rerunning every time you change one of these settings, what you can do is you can turn this auto run off. It means it would not evaluate and rerun the evaluation unless you're asking or pressing this button. Notice the green color. It shows that the tabular section is in sync with the graphical section. So if I come to bus again and change this to 0.8, for instance, 2000 amps, and press OK, you can see it turns into orange, right? Notice how easily I can switch between the zones, between the bus and coordination, and applied changes to one is represented in the other one as well. So it looks that they are coordinated, but still there are some overlap margin here, which you can correct, right? And if but you see it's still showing it as red because it's not been updated. So once you apply all of the corrections, you can press evaluate, and then all of the correction will be applied in a single shot, saving you more time and efficiency. The next item in our list as part of the features was evaluation report. I have showed you the dynamic update of evaluation result after applied correction. Let me show you the tabular report. I showed you the graphical report. For tabular report, as we have seen, you go to evaluation report. I've showed you before, so I repeat it again. This is for general, this is bus section, and this is for coordination. So it's providing the report for the portion of the evaluation. You can have different reports for different sections, different zones if you wish to, or you can have one for all. It's up to you and based on your desire. So as we have showed you, the Star Auto is combining all of the features of traditional procedures for doing protection and coordination, such as selection of the zones of protection, running fault studies, analysis the TCCs, and additionally creating the table as a result and report in a single engine based on your provided rulebook. Talking about the target users and incentives, if you are a novice protection engineer, typically you may need help and assistance. And our default rulebook in ETAP would be a great advantage that you can rely on, review the results, and make your own engineering judgment. If you are an experienced protection engineer, then the benefit or incentive for you would be the enhanced accuracy. As I have showed you in the rulebook, you have the proximity check, and this is something you cannot typically verify visual verification, right? The convenience and increased efficiency in navigation within the analysis viewer would be another major advantage for the experienced engineer. But let me show you one example of expanded design aspects and criteria, something that we may miss in our protection and coordination studies. For the same bus, right, let me go to the study case, Star Auto. And for the coordination, let me select both phase and ground and press OK. Let me run the evaluation for this bus only. And let me show you, as we have seen before, for the three-phase, the coordination was passed, right? But if I expand and then let me enlarge it that you can see the full screen. What you can see is for the three-phase between the main breaker and the fuse, there is a full coordination. But let's have a look for the line to ground fault. You may see a strange shape for the upstream breaker. If you left click here, you will see the program is intelligently combining the phase and ground protection element of the upstream breaker, because they both sense the same fault with different magnitude, possibly different magnitude of the true fault current, but they both will see their true fault. And the behavior or response of the breaker would be combination of the two, which the program is showing it for you. If you look at the two breakers, you can see it is doing the same for the upstream and downstream. And frankly speaking, this is something that some of us may have missed in protection and coordination study because of the complexity of doing all of this shifting and combining occurs in a single location. So this will be an additional powerful tool for experienced engineer to use their knowledge and expertise in areas that the program can help. If you are a protection team leader and you're supervising a group, the Star Auto can provide you with the capability to provide a general guidelines in a universal rulebook that could be given to all of the protection team members, so they can use the same rules, and naturally the result of evaluation for such rules would represent the consistency between different evaluation. Could be for the same project, could be for different projects. And as you know, one of the issues for the project is consistency between the rules between different projects or the same project, as I explained before. For a single client, if it is large, you want to split it between different protection engineer. Naturally, the criteria for such protection and coordination study should be the same for all of them. So the same rule could be used for all. On the opposite, if you have different clients and they prepare or use different criteria for their protein coordination studies, such as mining and refinery industry, then you may want to have different rules for each of your clients. So that would be another advantage, as you can see. I think so far I have explained all of the benefits, but to make it short and sweet and summarize everything, Star Auto can evaluate existing or as-found electrical network for protection and coordination studies, or it can be used as a tool for design a protection and coordination study in a new project. It can easily find and highlight the problematic areas you have in the setting of your protective devices and provides you with the messages and the proper value that you can use as reference for adjusting your setting. It will provide you with the possibility to navigate between different zones very efficiently and very conveniently. You have the option either to dynamically correct your evaluation results, apply the protective device setting changes dynamically, or if you wish for a larger project, you can use the static correction, do all of the correction in one shot and then apply it all at the same time. It would verify accuracy in the device setting for protection and coordination, proximity check, the margin, everything that you need in preparation of any report is provided in the tools available in the software. It will also verify the compliance with applicable standards, as I showed you in the Rulebook, standards such as the NEC rules and articles. And the foot of this application or this feature or this powerful tool would be increase efficiency in doing protection and coordination study, meaning saving the time in especially larger projects. And as you know, protection and coordination study is the prerequisite for doing any arc flash assessment. So it would help you a lot. I hope you have enjoyed this presentation.